Okay, in today's video, we're going to go over another problem involving acceleration without friction. And this is the situation we have. We have mass m1, which is sitting on the table. Mass m1 has a mass of 7 kilograms. The coefficient of friction between m1 and the table is 0. There is no friction between these two objects. This is the magic frictionless table. We follow the string over the pulley down to m2. m2 has a mass of 4 kilograms. All right, these two masses are attached by this massless inelastic string. The massless, and you guessed it, inelastic string passes over, that's right, the massless frictionless pulley. Now all of that means that we can basically ignore the mass of the string and the friction energy loss in the pulley when we release these two objects, because you can imagine we're holding m1, we release it and it's going to accelerate to the right, m2 is going to accelerate down, and we want to know what is the acceleration of those two objects and what is the tension in the string that connects those two objects. And to do that, we are going to use, you guessed it, Newton's second law. The sum of the forces equal to mass times the acceleration. We want to know what the acceleration is. The acceleration is equal to the sum of the forces divided by the mass. Now, I want to point out, these two objects are attached to each other by the inelastic string, the massless inelastic string. And that means they're going to have the same acceleration. m1 and m2 are going to accelerate at the same rate, and therefore we're going to apply Newton's second law to both of these objects at the same time, and that's kind of our system of objects, m1 and m2. Now we need to know the masses, where we're given the masses, 7 and 4, so that's pretty easy. We have to sum up the forces, which means we have to draw in the forces. Before we draw in the forces, we're going to assign the positive direction of motion, or the positive direction for each of these objects. m1, you should notice, is going to move to the right, so we'll say positive is to the right for m1. m2 is going to move down, so we're going to say positive is down for m2, or down is positive for m2, to the right is positive for m1. Okay, now we can draw in all the forces acting on both objects. That is the gravitational force for m1 and also the gravitational force for m2, m1g, m2g. All right, now each object is attached to each other by that string. That means there is a tension force acting on each object. The tension force on m2 points up in the negative direction, Ft, and the tension force on m1 pulls it to the right and is acting to the right, Ft. The last force is the normal force. The normal force points straight up, keeping that object from falling through the table. You should notice that F and the normal force and m1g are equal in magnitude but opposite in direction. Okay, I would say that's the end of step 1, determining the positive direction and drawing in all of the forces. Now we can apply Newton's second law. The acceleration is equal to the sum of the force divided by the mass. The mass is the mass of both objects added together, so we're going to put in m1 plus m2. And then we're going to sum up the forces, and we're going to sum up only the forces that are acting on the objects in the direction of motion, or that are affecting the acceleration. We're going to look at each object one at a time. For m1, it's moving to the right along the x-axis. There's only one force, the force of tension, that's acting in the x-axis, so we're going to put in plus Ft because that's acting in the positive direction. The normal force and the weight, m1g, do not affect the acceleration of the object. They're acting in the y direction. There is no friction. There's only the tension force on m1. For object number 2, there's two forces because object number 2 moves in the y direction along the y-axis, and there's two forces that are acting along the y-axis. That's Ft and m2g. Ft, as we mentioned, points up. Down is positive, up is negative, so we're going to put minus Ft. m2g points down in the positive direction, so we put plus m2g. That is the summing of all the forces that are acting on those two objects that affect the acceleration of those two objects. You will notice we have plus Ft and minus Ft. We have an inelastic string. That means that those two forces are equal and opposite in direction, equal in magnitude and opposite in direction, so therefore they're going to cancel each other out. So when we reduce the equation, we have m2g divided by m m1 plus m2. That tells you that this is the equation that affects that we use to calculate the acceleration. And you can see there's really only one force, m2g, the weight of m2, that affects the acceleration of those two objects. Now we can plug the values in. m2g is 4 times 9.8 meters per second. The sum of the forces is 11, and that means the acceleration is 3.56 meters per second squared. That is the acceleration for both objects. Summing the forces, dividing by the masses, gives an acceleration of 3.56 meters per second squared. That's the acceleration. We said we're also going to get the tension in the string. So now we're going to find the tension in the string. Once again, we're going to use Newton's second law. We're going to sum up the forces. But in this case, we're going to sum up the forces on each object individually. We're going to apply Newton's second law separately to each object and solve for the tension. For m1, we get that the sum of the forces is just the tension force, because that's the only force that affects the acceleration, and that's equal to the mass of m1 times its acceleration, which is 3.56, not 9.8. We plug the numbers in, 7 times 3.56, and we get that the tension force is 24.9 newtons. Now you can check your whole problem, because you're going to use your acceleration. We can apply Newton's second law to the second mass. In this case, it's minus Ft plus m2g equals m2a. Those are the two forces that are acting on m2. Remember, we're applying Newton's second law just to mass number 2. We're going to rearrange the equation to solve for the tension force. We're going to move m2g to the other side, multiply the whole equation by -1, and we get that the tension force is equal to m2g minus m2a. This g is 9.8 meters per second. This a, this acceleration, is 3.56. And if you do that, you also get 24.9 newtons. Okay, you can see the forces are equal in magnitude, but opposite in direction. All right, so that's the whole thing. That's the acceleration and the tension. Thank you very much for watching. I hope you found it helpful. If you did, and you want more videos, please subscribe. Click on the subscribe button. If you found it helpful, you could also give me a thumbs up or leave me a nice positive comment in the comment section below. Thank you very much for watching. We will see you in the next video.